if you look at your green books, you'll find that it starts off with the universal formula on the first page, or after the contents page anyway. Yeah. And then if you go through flick through the back of the book, you'll see that all different products are listed with their main classes of ingredients. Okay, so we're in our green books. The first page was the universal formula, and I'll run through that, and I'll explain how that works. But in the back of the book, you've got all different types of products, the main products that we'll come across, such as shampoos, conditioners, air fresheners, potpourri, reed diffusers, fabric softener, yeah, all the sort of products that use perfume. And in front of you, you've also got some products, yeah, and these products have been listed, these bottles, because they have the ingredients listed, yeah, according to EEC regulations. For local products, not, but for international products, yes. So the idea is that when we look at product applications, the idea of the universal formula is that formulations have things in common. The universal formula that you have in your books gives you an idea of what the basic functions of the materials are in a product, common to all products. Yeah? And you can look at the ingredients and more or less guess how much there is of each ingredient, yeah, just from that list. So you can then reproduce that base, yeah, quite easily. Yeah? It's not for the purpose of copying the base, but this is from the point of view of the perfume. How will my perfume be affected by the product that I put it in? And how do I optimize my perfume for the product that I put it in? So if you pick up one of these bottles, one of the liquid ones, what's the most common ingredient, the solvent? Water, aqua, yeah. So the first thing we find in almost every product is a solvent of some sort or a carrier. And this will make up 60 to 80% of the formula. If it were like a powder, talcum powder, what would be the main carrier? Talc, yeah? Yeah, mineral talc. Yeah. If it were a massage oil, what would be the main carrier? The carrier oil, yeah? It's actually called carrier oil, yeah? So it carries the active ingredients. And then if we look at air fresheners, we have alcohol for the spray, yeah? If we look at paper air fresheners, we have paper as the carrier, yeah? So that's the main part of the product. The next common ingredient we find in most products is a thing called a surfactant. What does the word surfactant mean? Yeah, surface active agent, yeah? So a surfactant is a molecule that has a lipophilic, which means loves fat, yeah, part, and has a hydrophilic part. Why does shampoo wash the hair? Anybody ever put plain water onto your hair? Yes? Tried to wash your hair with cold water?
Just change the texture.
Warm water? It doesn't really wash the grease out, does it? Yeah? Because we have oil and water. Oil and water don't mix. So the surfactant is a molecule that has a fatty part and a water-loving part. Yeah? And what happens is that in the grease on your hair, the fatty part of the surfactant sticks to the grease. Yeah? So if you imagine a little blob of grease in your hair, and all these surfactant molecules stick to the grease, but then you bring water along, what does this look like now to the water? Because of these little hydrophilic or water-loving heads, to the water, it looks like water. So the water can pull the grease off of the hair. Yeah? That's how a surfactant works. Yeah? The simplest surfactant of all is, one of the oldest, is soap. Yeah? How's soap made? Most of you have already told me this. Caustic soda and fat. So the fat comes from oils, palm oil, fatty acids, yeah, from palm oil, coconut oil, olive oil, sunflower oil, mostly for industrial soap. When I say industrial soap, I mean common household soap. We're looking at coconut oil and palm oil and maybe tallow, yeah, tallow from animal fat. So that gives us the oil part. We then react this with sodium hydroxide, and it gives us a charge with the sodium on the end, which is attracted to water. Yeah? So when we react sodium hydroxide with palm oil, yeah, we get something called sodium palmate. Yeah? If we took a specific acid, myristic acid, and reacted it with sodium, we will get sodium myristate. So who's got the imperial leather? Imperial leather? Andy? Yeah? I buy this in bulk, yeah? What's the main ingredient on the soap?
Sodium palmate.
Yeah, and then?
Sodium palm, creamylite, salt,
Yeah.
perfume.
So it's the sodium. So solid soaps are made of sodium hydroxide. They're simple. They're the simplest surfactants. Yeah. If we wanted to make a liquid soap, who's got the Glycerine vetiver? So what's the main ingredient on that one? Potassium. Can't read it.
This one is not. I don't think it is. I think it's a shower cream. This one, it's not a liquid soap, so it'll be
Isn't it?
base rather than
Oh, which is the one? Which is the one I meant to do in this? Oh, that's funny. Okay. So sorry, that's a surfactant-based one as well. But if it were a liquid soap, a true liquid soap, it has potassium, uses potassium hydroxide with the oils, and we get the potassium on the end, and this is used for soft soap or liquid soap.
What is killing the bacteria?
Sorry?
What is killing bacteria? On a soap.
Yeah, I don't know why it's so successful. Yeah, I don't know why it's so successful, but I'm guessing it's something to do with this charge. But yeah.
Yeah, because I would think it's good for the greasy,
Yes.
but then the bacteria.
Well, I actually just said this to Rick in a way because he said like, which of these products do you use? Yeah. And I said I only actually ever use Imperial Leather soap, even for my hair.
Right.
Yeah. Because I find it controls athlete's foot and all sorts of things. Yeah. Because it kills. Yeah. Because it. Yeah, athlete's foot on my head. Yeah. because it controls bacteria and stuff. Yeah. Which most shampoos don't. Yeah. They feed the bacteria, yeah? And I'll come on to why they feed the bacteria in a minute. Sorry? I very rarely use shampoo. Yeah. Sorry? Use soap. Yeah. But if you have long hair, I wouldn't recommend it because it'll make it too. Yeah. It's all right for like this.
Yeah.
Brush. Yeah. I think it washes the colour out actually. So soap is the simplest anionic surfactant. Oops. So I suppose I jumped forward there. Thank you. So, cheers. So the next class of that's an anionic. That's called an anionic surfactant, the soap, because it has a negative charge. It means it goes towards the anode, which is the positive charge on a when we do electrolysis. The next anionic surfactant are the most common ones: sodium lauryl sulfate, sodium lauryl ether sulfate. And if you look at your shampoo products, most of you will have those in there. Ammonium laureth sulfate. These are chosen because anionic surfactants are very cheap to make. They produce good detergency, which means they wash oil out very well, and they have big bubbles. They produce big bubbles, big unstable bubbles. Yeah. So if you were doing something like a car wash product, you would tend to only use something like sodium lauryl sulfate. Yeah. So big bubbles, lots of foam, good detergency, good wetting properties. And your clue to those names are like they say alkyl and alkyl ethoxy sulfates. Sodium lauryl ether sulfate, ammonium laureth sulfate, sodium lauryl succinate. Yeah, are samples of the common names you'll find. Yeah, for anionic surfactants. I'm going to go down and then go to the last one, to the first one last. The next group of surfactants we get are the cationic surfactants. And these have a positive charge, and they have names usually with the name quat in them. Quaternary ammonium salts.
What's the difference between anionic charge and anionic salt?
It's just that a soap is specifically for this reaction of sodium hydroxide or potassium hydroxide with fats. Yeah. The anionic surfactants are produced by a different process, but they start with oils as well. Yeah.
An ionic soap was made in the same way with the non-ionic soap.
There's not a non-ionic soap. All soaps are ionic. Yeah. The non-ionic surfactant. Yeah. Okay. Yeah. I'll come to non-ionic in a minute. Yeah. Where was I? Oh yeah, so cationics, they have a positive charge. So they're good anti-static agents. Yeah? So they're used for conditioning. They don't have a lot of foam. They're slightly more expensive to produce. And you can't make clear solutions of them. So if you imagine that you wanted to make a 3-in-1 shampoo, could you make a 3-in-1 shampoo by mixing the anionic surfactants for the good cleaning and cationic surfactants for the conditioning? Anybody see what the problem might be? They cancel each other out. What happens is the positive tail and the negative tail fix together, and you get a huge molecule which falls out of solution. Yeah. So it doesn't work. You can't make a 3-in-1 like that. Yeah. The next group of surfactants we get are called zwitterionic or amphoteric. I don't know why the change in name. They used to, 20 years ago, they used to be amphoterics. Now they're all called zwitterionic. Zwitter means just switch. Yeah, it's German for switch. Switch their ions. These are usually based on protein molecules. Yeah, they're surfactants produced from things like tallow. Yeah, so proteins in the oils. And they produce a molecule that can change from a negative to a positive charge depending on the pH of the water. So this is where the 2-in-1 shampoos come from. They have names like betanes. Usually you see the name betane, yeah, or amine or something in the name. This indicates that they have this protein structure. Because of the protein structure, it's closer to our skin, they tend to be very mild on the skin. They produce very fine bubbles. Yeah? And those fine bubbles last a bit longer than the ones from the anionic. But they're not quite as good as detergents as the anionics. So these are minus or plus. Small bubbles, small fine bubbles, and quite stable. And last but not least, we have the non-ionic surfactants. And these are things like polysorbate, sorbitant isostearate, polyethylene glycol. And if you notice in those names, sorbate, glycerol, what are these? They're alcohols, but they're sugar alcohols. They're sugars. So they're good food for bacteria, really. Yeah? They're good food for organisms, sugars. So, but as non-ionic surfactants, they have low but stable foam. Yeah? They're fairly mild to the skin. And the other thing they can do is they can mix with any of the other ones. Yeah? So if you look at baby shampoo, who's got Johnson's baby shampoo? The main polysorbate, yeah, the polysorbate, yes. Okay, so what we have is the non-ionic and some anionic surfactant in there too for the washing. Yeah, and there's probably, if you go down further, something like cocoa amido propyl betaine. I'm guessing because I can you see any betaine? Laurel betaine. Yeah. So, yeah. So to make Johnson's baby, they have the polysorbate, a non-ionic surfactant. They've mixed it with some anionic surfactant to give it some bubbles, and then some zwitterionic or amphoteric surfactant to make it good for the skin, to make it the bubbles more stable, more small, finer bubbles. Yeah. Okay, that was the one I was looking for. Anybody got the yellow one? Yeah. Main ingredients? Yeah. Jasmine, yeah. Pure jasmine oil, yeah, okay. Yeah. What's the first ingredient on there? Water. Second? Lauric acid. Next one? Acid. Next one? Potassium hydroxide. So what have we got there? Lauric acid, myristic acid, potassium hydroxide. We have a liquid soap, yeah? So they've listed the ingredients not as potassium laurate or potassium myristate. They've shown the individual ingredients to produce the liquid soap. And then if you go further down, is there something there like lauryl ether sulfate? Sodium lauryl sulfate. So that acts as a foam booster for the soap. Yeah, gives you extra. It's soap based, but there's a little bit of surfactant in there to give you this better foam. Okay. Now, the other function of non-ionic surfactants, according to basically the proportion of the hydrophilic part to the lipophilic part of the molecule, yeah. So if we get like a bigger part to this, yeah, what we get are emulsifiers, or we get solubilizers. So what's an emulsifier?
Something that would mix oil and water together.
Something allows oil and water to mix together, yeah? And a little bit like that oil droplet, what we can do is actually get a whole droplet of an emulsifier, yeah, and we have to choose the emulsifier according to whether it will turn inwards or outwards here, yeah. But we can get oil to float in water, yeah, a cream, an emulsion. Milk is one of the most simple, yeah. So this is called an oil in water emulsion because the oil is floating in the water. Oil in water emulsion. Water, here the heads are on the inside, yeah. Oil, and so this one is called a water in oil emulsion. Any question? And is that clear what that's doing? Yeah. Sorry.
What's that used?
Every emulsion, yeah, that you come across, a mixture of oil and water uses these two basic principles. It uses oil in water or water in oil. Generally speaking, the oil that floats in the water is like a lotion. Yeah, it's a lighter form of cream. If you get a night cream, there's some exceptions, but generally the water floating in the oil is like a moisturizing cream. So this is lotion, this is cream. And why this becomes important, we will see shortly. why is the emulsion white? I mean, sometimes it's a little bit off-white, but almost always it's white, it's creamy. Why is the emulsion white? Okay, so if you remember that thing we talked about called refractive index, when light hits a surface it bends, yeah? So what happens when you look through an emulsion, the light bends, hits another one, hits another one, hits another one, and the light bounces back. So that's the reason why all emulsions are white. Yeah. Nowadays with nano emulsions there's a slightly different thing going on, but that's basically why emulsions are white. That's why milk is white, why cream is white. Because it eventually reflects everything back because of this refraction, yeah, of light. Bending at each surface. Sorry?
Nano, it just stays in.
Well, nano, what happens is that the micelles, these are called micelles, are so small that it can pass straight through. Yeah. Okay. So surfactants will typically make up about 10 to 30% of our formula. Of our formula. The next ingredient that we will get frequently in our products are emollients. Emollients, which will make up 10 to 20% of our formula. So emollients are what? What does emollient mean? Something from the, yeah. Emollients. Like oil. What's the purpose of an emollient? Yeah, moisturizer to soften the skin, moisturize the skin. Yeah, something like that. So the first one would be, example would be oils and silicones. Yeah, silicones in hair products. So if you look at something like Sunsilk products, the black one, Rick, can you have a look at that? Is there a, can you see something called dimethicone or cyclomethicone?
Yes, dimethicone.
Dimethicone, yeah?
Dimethicone.
Anybody else got Dove? Probably got some in there? Oh, your eyes, yeah. Any other yeah. There? Which methicone? Emodimethicone. That's too small for me to read, actually, that one. I believe you. Yeah. It's a silicone, yeah. The things with the C-O-N-E on the end, yeah, are silicones. Then you get moisturizers like lanolin. Lanolin is made from sheets. We have lots of New Zealand people from New Zealand, so they should know this. Yeah. Then we get a group of materials called humectants. Humectants are very often glycol, which is sugar type based compounds. So if you put sugar on a plate in a room, particularly a room like this in this country where it's humid, what happens to the sugar? It becomes wet because it absorbs water from the atmosphere. Yeah. So glycols do this to the skin. The idea is that we put on propylene glycol, butylene glycol, glycerine, yeah, and they suck water from the atmosphere. Yeah. Hydrating agents. But there is another thought to that. Where's the nearest source of water when you put propylene glycol on the skin? In the skin, yeah? So depending on your thinking, yeah, glycerine, propylene glycol, butylene glycol may actually be drying to the skin. Yeah, they may actually make it moist in the sense that there's a wetness there, but the wetness may not be in the cells, it may be on the outer side of the cells. Yeah, so for me, glycerine is not too bad, but propylene glycol and butylene glycol, which they use as humectants to absorb water, I wouldn't choose them as good products to use. Yeah, make sense? Or?
Sort of restricted to about 5% in a finished product. Otherwise, if you go over that, it then starts to have a
Drying effect.
with
Yeah.
glycerin or
With glycerine or yeah, but with PG, I mean, I wouldn't, I can't see that it does any good at any stage.
no,
Yeah. But glycerine is not too bad, I don't think. And the other method of moisturising the skin are film formers. Things like petroleum jelly. Yeah, causes a film over the skin, stops the moisture evaporating from the skin. Yeah, and so keeping the moisture that's there in there. Yeah, and then many creams use a combination of all of these factors. Yeah. Next part of our formula, regulators to regulate the viscosity. Between 1 and 5%. Thickeners, plasticizers. What does plasticizers mean as opposed to thickener? To make it more plastic, to make it more soft. Yeah. So things like hairsprays, yeah. Some of the gums, yeah, and the resins used are very strong. So to make them softer and more flexible, yeah, there's a plasticizer in there to make it soft.
Make it hold without making it brittle.
Yes, yeah. Stabilizers. An emulsion is inherently unstable. So if you mix water and oil together, it wants to separate. Yeah. You cannot stop that process. But the idea is to slow it down as much as possible. Yeah. So if you increase the viscosity, you can slow down that process of the molecules finding their own levels and separating into water and oil. Yeah. And sometimes you can do it for many years, yeah, if you make it thick enough. But inherently, in the end, after 100 years, I'm sure every single cream would separate into water and oil. Yeah. And that's the problem with milk. Natural milk, it doesn't have stabilizers in it. Yeah. So it will separate in 2 or 3 days. And acids and alkalis to regulate the pH. So one of the common thickeners used in shampoos is actually salt, regular household salt, sodium chloride. And what the salt does is it adds a charge to the water so that when the surfactant molecules try to go over each other, they're slowed down by the attraction of the salt. Yeah? So when you add salt to an anionic shampoo, it becomes thicker. So you can make a really thick shampoo just using maybe 10% of surfactant. Yeah? But if you overdo it, it does what happens is it says it salts out and then it becomes thin again and you can't repair it. Yeah? But one of the things that's also used for combating the effect of the thickness of salt is to use citric acid in a formulation, yeah, and that thins the shampoo back down. So citric acid sometimes in the formula, it could be there as an AHA to alpha hydroxy acid for some acidic benefit to make it close to the pH of the skin, but it can also be in the formulation to regulate the viscosity.
Does the viscosity always work on pH then?
No, no, it's not. It's not so much to do with pH. I'm not quite sure why citric acid does it. Yeah.
So I was thinking if there was a couple of different surfactants that I've used that if you add not citric acid, one with the milk.
Lactic acid. Yeah, lactic acid. Yes.
So you add that.
Yeah, you could use
and
lactic.
then it gradually increases the viscosity, but if you add too much, that's to do with the pH. It just tips it back.
It takes it back the other way again. Yeah, yeah. But lactic acid has the benefit that it's antimicrobial as well. Yeah, so it's used in like female washes and things. Yeah. And sodium hydroxide, citric acid can also be used as to regulate the pH. There are other things you can use, triethanolamine, other things to get the pH right, but sodium hydroxide is quite a common one, and you'll probably find it on some of these products here. Okay, so then we come to the actives, and these are the things actually that sell the product, and they're usually only about 1 to 3% of the product. Herbs, vitamins. So these actives are usually the USP, and every product needs a USP, unique selling point, yeah, a unique selling proposition. Yeah, it can be anti-dandruff, UV absorbers, antioxidants, AHAs, skin softeners, etc. Whitener, yes, yes, the whitening agent. Okay, yeah, actually that's a good point actually. Can everybody look at a product and see if you can identify what the unique selling point of that product is? Okay, so that's that. Okay, whitener. Sorry? Cooling, so it's cooling, yeah, it's got menthol in it probably. Yeah? Can't read it. Sorry?
Natural botanic fragrance.
Yeah, so a botanical extract of some sort.
Theory for clove.
Yeah,
And citronella.
clove and citronella, that's the natural,
It's
yeah.
also got fragrance, but that could be anything, right?
Yeah, that could be anything. Any unique?
The rice germ oil.
Rice germ oil.
There's nothing in this one. Just chemicals. Intense repairs.
Intense repair, so we'd have to find out which one that is, and I can't read it either. Yeah, yeah.
This has got potassium hydroxide in it.
It has. Yeah, I thought it had. Yeah.
It's weird, this has got two different labels on. One that says like a really small, nice looking one, and then
Yeah.
a real one.
Oh, okay. Oh, so maybe I looked at that one. Yeah.
Yeah, potassium soap it's got there, but then potassium hydroxide is quite far down. There's sodium sulfate.
This was actually one done for the king in Thailand. This one. And then Giffarine took over production of it. Did you find unique selling points? And also, actually, the lack of perfume is one of the selling ingredients of Clinique. Yes, yeah. That one's like colour. Yeah, you might be able to find the ingredients that wheat germ, honey and wheat germ essence. Yeah. Okay. So far, all of these ingredients are just to carry the most important ingredient of all, which is of course the perfume. And so typically a perfume will be in the range of a normal product, about 0.5 to 1%. Yeah. I'm taking cosmetic products as a base here. And I include in those essential oils. Next range of materials we get are preservatives. Antimicrobials, UV absorbers, antioxidants, things like that. Have a quick look, see if you can find something that's antioxidant or...
Usually on creams.
Sorry?
Usually on creams.
So on the creams you'll find them in probably these two. Can you find any preservatives?
Preservatives. Benzophenone.
Yeah, benzophenone. Is that benzophenone 2? Okay. Any preservatives?
I can give you one from Poland.
Yes, I do it here.
Can you find any preservatives?
Yes, go.
All over the world. It's not for me.
Is he in New Zealand?
Yeah.
No, he never, actually he never went out.
Show me that. This is Thailand.
$2.
In this one has sodium EDTA. Yeah.
Can I see what?
Any preservatives?
Sodium EDTA, is that a preservative?
Effectively, because what is there is to as an antioxidant. Sorry? Yeah. Yeah. Yes. No, actually, that's what it does. The antioxidant property comes from the fact that it chelates any iron. Yeah. Which acts as an attractant for oxygen. So if you imagine in a product, you get they're mixed in stainless steel containers, stainless steel vats. You get traces of iron, and that iron acts as a magnet for oxygen in the final product.
What product were we looking at that has got EDTA? Why would they have iron in the product?
I just told you, the mixing containers. Yeah.
So not everybody's using stainless steel tanks.
No, even stainless steel, you can get traces. To sodium EDTA in the soap, in the rollers. Yeah. Sorry? Yeah, methyl and propylparaben, yeah, good examples. Usually about 0.1%. And last but not least, colour. Colour will be there in trace amounts. Okay, so that's an introduction to the universal formula. Sorry? Lakes. Lakes are colours used for colour cosmetics. Because the colours are not very stable on their own, what they do is they get aluminium particles and they coat the aluminium with colour. Yeah. And then the colour becomes stable and used for lipsticks and gives a little bit of shine to lipsticks and things.
Are you allowed to use these anymore?
Yes.
So recently there's been change in what colors you can use, right? Like you can't use oil-based colors anymore, at least in foods.
Check because, but they're still used all over the world over. Yeah, all of these. Yeah, pigments. The food were definitely used in colours are used, but they have EEC numbers and yeah.
They're all water-based. What I was
Yeah. Oh, okay. Yeah, mostly, yeah. They're not so stable, so they're not so good for cosmetics because they fade. Yeah. Yeah. Okay. So you have a universal formula. Now, what I would like you to do for your workshop, yeah, is choose one product that you have on your table, go to the page that refers to this for your product. So get your product, let's say you've chosen a shampoo, then on the page that you refer to, you'll see there's a space for a formula at the bottom. Try to write the formula based on the universal formula of the product, yeah? Try to guess the formulation of the product. Yeah? So you have those ingredients, yeah? And then put them in the necessary boxes. And then guess the percentages. Remember, they normally list larger amounts than smaller amounts.